Okay, so in this next lecture segment about electrochemistry, we're going to look at a couple different problems that occur in electrolysis. And the first is figuring out how far the electrolysis actually goes. So we want to be able to include the amount of electrons involved in the reaction in stoichiometry of redox reactions. You apply electrons, electrons are a reactant, and so the electrolysis will only go as far as you supply electrons to it. So what does that mean in terms of the stoichiometry of the redox reactions? And we'll also look at reactions that you don't want to happen, but happen anyway. How can you, look at those redox reactions you don't want to occur, and how do you mitigate that happening? Okay, so stoichiometry of electrolysis. This is relatively simple. In an electrolytic cell, the amount of product made is related to the number of electrons transferred. So all you have to do to figure out how much product occurs is how many electrons did you add? So the number of moles of electrons that flow through the electrolytic cell depends on the current and the length of time. That's the key. If you can measure the current, that literally is the number of electrons, in the proper units per unit time. So if you know what the current is, and you know how long you ran it, you can figure out how many electrons were added, and therefore how far the reactant went. So 1 amp is just 1 coulomb of charge per second. And of course, you need to know for the stoichiometry how many coulombs are there per mole of electrons, and that's just Faraday's constant. 96.45 coulombs of charge per mole of electron. So those are the basic ideas. So let's look at a problem here. Copper can be plated out from a solution of copper 2 plus ion. What mass is plated out by a 5-minute flow of 2 amp current? Okay, let's see. So diving in, we want to know how many electrons were added. But if we've got 5 minutes, then an amp is a current per second. So we have to go to 1 min 60 seconds. Those cancel. And then an amp is going to be a coulomb per second. So 2.0 coulombs per second, seconds cancel. And then we want to convert to moles. So we got 96485 coulomb per 1 mole electrons. And we know that to make 1 copper ion, we need 2 moles of electrons to make 1 mole of copper. So those cancel, the coulombs cancel. And finally, we're looking at mass. We just need 1 mole of copper, 65.33 grams. And so that's just a plain old stoichiometry problem. You get 0.20 grams copper. Okay, so that's straightforward enough. When you're doing the stoichiometry there for an electrolysis problem, you have to remember, you have to force it by adding electrons. How many electrons did you add? That'll tell you how far the reaction went.